as Fredrik said, I'm working in the SN2 group, the architecture group, and I'll spend now a few minutes to explain what in this architecture group that we have done to address these non-public networks from the generic angle. And then we have separate work for instance, the time synchronization and other aspects, but I'll here focus on what has been done in RIS 16 and 17, where they were working ongoing for addressing the non-public networks. So first to recap, so basically non-public networks or private networks have been possible to deploy earlier also with cellular systems, but it's not until now, RIS 16, would have more explicit support for addressing this vertical market, and especially when there is an anticipated grow on a number of networks available, for instance. So the mindset has been that a non-public network is intended for limited number of users. It can be enterprise in a specific geographical area, and the use cases can vary, but this has been the main consideration as such. And for addressing this, looked into two different architecture models. One that now Ian also explained, that you have one is that more integrated with the PLMN of public network, and that is offering connectivity for the non-public networks, these vertical networks, and one where you have more a standalone, that this can be deployed quite independently in various parts of a country, or in a mine, or in an arena, for instance, addressing your needs. So basically, there are many different ways on how you can deploy this. PP offers a flexibility by specifying the interfaces as such that to enable the interoperability, and actual deployment can therefore be quite flexible. These are just a few examples. Starting from the right-hand side here, taking like a factory as an example, this would be a standalone network, and you basically have all the equipment as such in your vertical control. And then some different levels of integrating with a public network. First, here on the left-hand side, we can share the base station, the radio network, and this could be located inside on premise, close by, or even on different locations. But the point is that here you have a shared radio, and this is going that the devices can select either the public network or this non-public network here, and the only common part is then this base station or radio network then. And then there are different levels of sharing also the 5G core networks here. You're sharing a RAN that can be located inside or outside the premise, and more on the user plane for addressing the media and IP packets, for instance. And then here, this can be, in this case, the public network is giving entities to control how you manage and handle the user plane data. And in this way, this option here is basically the core is outside inside the public network, and you only have the RAN and the basically the application environment robots or something like that in the factory. Everything else is managed by the public network, and there are variations of this. As I said, these are just examples of how it can be deployed. More options are possible. This is a busy slide, but I will just point out some of the differences or comparison of this standalone and when it's integrated with the public network. One of the main reasons was that when you deploy a standalone network, there will not be enough number of identities of the networks. So we added a network ID in addition to the common known PLMN identity. So this will be give a large opportunity then to address the standalone non-public networks. And there can be any combination of quite flexible. So you can have this country code in the 900 series is globally for the whole world, and then you can have also certain countries have assigned network codes specific in the country for non-public network use. So this is also allowing any combination you want. And this NID, this can be self-assigned more like the non-public network administration itself assign a number, or it can be more coordinated. You can use public enterprise number from IANA, for instance, to create this NID. Whereas in the public network integrated case, you basically address with the operator's PLMN ID, and then inside the network, you either have a slice separation with different slices, or you have a data name so you can address a specific data network. The different ways on how the public network can aid your vertical needs for addressing it in the public network itself. Another difference is in the standalone, this what you call the USCs, USIM or eSIM, different variants is not required. You can have certificates-based authentication, for instance, whereas in the public network you require a USCC as such. We will not go through the rest here. So still staying in V16, basically also enable the possibility if you, for instance, have your deploy your non-public network, but if you have the device itself also have a USCC, you could move outside of your business, your arena, and then you can still access the services over a tunnel, IP tunnel, IPsec tunnel, into what we call an entry into working function, and address your services on the premise, basically remotely. And there is some form of a basic mobility in these cases, but it requires basically two sets of credentials, one for the public network and one for the non-public network. That was the release 16 enhancements on a high level. The 17, this is the ongoing work. I'll go through 4 points. One is basically now when we have this standalone non-public network, and that I think Lola also mentioned in the slides, that the wish to, if you have using credentials that are not really from this non-public network, but use other credentials, this can be a PLMN operator, it can be another non-public network. The credentials from this network can be used to actually access this network here, this SNPN 1, for instance. So when you do authentication security, basically using credentials from what we call a credentials holder. And these can be grouped as well when you discover these networks. So there is specific group identities that are used during network selection to ease the find these networks that enable this type of functionality. Okay, and then besides on a high level, basically from the media and the requirements perspective that are on the KPIs and so on, we didn't find any need to do any further architectural changes. So basically to address scenarios like this that Ian also showed, comes from the TR that Ian worked on. There are no required changes, but you can use the current V16 architecture to address these media production use cases, basically. And if that is not the case, then we need to come back to them. But we'll need to discuss this further if there are anything missing, basically. And then short, we also, in V16, this standalone non-public network didn't support IMS voice or emergency. So IMS is this IP multimedia system that is using SIP and FTP for transporting control and enabling voice support. That was not supported in V16. Enabling in this 17, and this IMS can be part of the SNPN or it can be separate. And then finally, that I think Lola also touched upon in the slides on some of the important aspects on the on-demand or onboarding functionality. We're also enabling what we call UE onboarding. So enable with a cellular system some temporary connectivity for being able to provision non-public network credentials to the device. So the device is assumed to have some form of default credentials, can be a certificate, for instance, and then using this, the UE will find a network that provides this ability, doing authentication to secure that device is what it says, and the network is non-rogue, and then enabling a provision of these non-public network credentials that can be, so there can be a subscription owner that have basically created a subscription and these credentials, and these are then provided to the device, and then afterwards it basically go and select a network that are using the credentials, NPN credentials that have been provisioned to the device, to the UE.